Hello, this is question 5 on your June 2023 mechanics paper from Edexcel. You have small ball is projected with speed 28 meters per second from point O on a horizontal ground. After moving t seconds, the ball passed through point A. The point A is 40 meters horizontally and 20 meters vertically from the point O. And the motion of the ball is modeled as particle moving freely under gravity. Given that the ball is projected at an angle alpha to the ground, use the model to show that the time up to here is 10/7 cos alpha. Yeah, so the particle is here when t is this t. We have, remember, in projectile questions, we can work independently with the horizontal motion, which is constant velocity. This velocity here is going to be, if you look at this right angle triangle, is adjacent to the angle. So it's going to be 28 cos alpha, even if we don't know alpha. And the vertical component is going to be sine, because it's the opposite. Yeah. So this is 28 sine alpha. If we look at the horizontal motion, because it's the simplest, the horizontal motion is constant velocity, vertical motion is under gravity. So if we look at the horizontal motion, we can say, I'm going to do the next page. So horizontal motion, as is constant velocity, velocity is distance divided by time. So up to A, the velocity is constant, and we say is 28 cos alpha. Is going to be horizontal distance, that is 40 meters up to A, divided by t, which means that t is 40 divided by 28 cos alpha, and when we simplify, divided by 4, t is 10/7 cos alpha. Yeah, and that's the first part that we have to prove. This is A. Then for B, just using the horizontal motion, remember we can isolate them completely. So that tan squared minus 4 tan alpha plus 3 is 0. It's 5 marks. So now we are going to combine this horizontal motion with the vertical motion. Vertical motion is it's like a particle projected up with this initial velocity. Yeah, it's like those questions that you do in year 12, where you have something projected upon a point going up and then down. Yeah, we have A here, and this distance, vertical distance, is 20 meters. 20 meters. Yeah, and we know that this velocity is 28 sine alpha. So if we apply subat to that, and we consider positive up, for example, displacement is going to be from O. So from O to A is going to be 20 meters. Yeah, remember, it's the difference between the initial position and the final position, not the distance. Initial velocity is the projection velocity, which is 28 sine alpha. Final velocity, we don't need. Acceleration is going to be the minus gravity, because I'm considering positive up, gravity is always down. And the time is going to be the same time than the vertical motion, the horizontal motion. Yeah, so this is considering the vertical now. We can write a subat equation that connects them all. One without v, because we are not interested in v, which is this one. S is ut plus 1/2 of at squared. Yeah, acceleration times square. So 20 is going to be 28 sine alpha minus g halves times squared. And well, I'm going to write time. No, sorry. I'm missing the t here in this one. So this is the initial velocity times by t. This t, we are going to use the expression that we found from the horizontal velocity, because if you look at your equation, we have only alpha, and that will help us to eliminate t. Yeah, so, and to have sine divided by cos, which is tan, 7 cos alpha. Plus, in this case, minus, because the gravity we say is negative, g divided by 2, and then the time squared. So let's go to see what we have. Sorry, we have 20. If we multiply this, we have 280, and then divided by 7. Well, we can divide the 28 by 7, which is 4, times 10 is 40, and sine divided by cos is tan alpha. So we have 40 tan alpha. And in this side I have, what can I divide? I have 100 divided by 49 and divided by 2. So 100 divided by 2 is 50. So I have 50g divided by 49. So minus 50g divided by 49, and then reciprocal of cos squared. Remember, reciprocal of cos is sec. So the reciprocal of cos squared is going to be sec squared. Yeah, I can change this by sec squared. And I'm going to simplify a bit. So I'm going to simplify dividing by 10 everything. So I have 2 is 4 tan alpha minus 5g over 49 reciprocal of cos squared, which is sec squared. And we are very close. So we have 4 tan, we have minus 4 tan, and then we need tan squared. Remember, we have an identity that relates sec squared with tan squared. Yeah, we can substitute that by tan alpha minus 5g over 49, which is 1 plus tan squared. And believe it or not, this is 1. Yeah, so 5 times 9.8 divided by 49 is 1. Yeah, so I have 2 equal to 4 tan alpha minus 1 minus tan squared with squared alpha. Yeah, I'm just expanding the bracket. So this minus multiplying 1 and the tan. And now we reorganize. So we have tan squared minus 4 tan, and then I have 2 minus minus 1, so plus 3 equal to 0. Yeah, and this is the expression that we had to prove, which is this one. So it comes from combining the horizontal motion and the vertical motion together. Then find the greatest possible height in meters of the ball above the ground as the ball moves from O to A. We have, again, remember this situation when I projected something up and then it goes down. This was A somewhere. We need the maximum height, which means we are just going to work with this first part of the motion. Yeah, and we are going to use subat. If we need the height, we need definitely to work with the vertical motion. So if we write subat, displacement, maximum displacement is what we need, or maximum height. The initial velocity is the 28 cos alpha. Final velocity at the top is 0 because then it stops and then reverse. And acceleration is minus 9.8 if I consider again positive up, and we don't need the time. But we cannot use, they say the height, it doesn't say in terms of alpha, it says find the greatest height in meters. Yeah, so to find alpha to be able to find this value. To find alpha, I'm going to solve this equation. It's a quadratic. We will get to values of alpha and then we will have to decide. So let's go to solve that alpha. We have it's a quadratic, yeah, so it's like having x squared minus 4x plus 3. If we factorize, we have tan alpha minus 3 and then tan alpha minus 1 equal to 0, which means tan alpha is 3 or tan alpha is 1. We do tan minus 1 with the calculator, and this gives us an angle of 71.56 degrees, and this one an angle of 45 degrees. We have two options because there are two ways of passing this point projecting from here. So a larger angle will go up and then down, and a smaller angle will go this way, up and then down. Yeah, so it's like on the way down or on the way up, which means we have to choose the largest angle if we go passing A on the way down. Yeah, so our answer our alpha is going to be this one. And this means I can write the initial velocity as 28 cos 71.56, which is 26.56. I am going to keep the numbers with all the decimals in the calculator. Yeah, I'm just rounding to write it, but I'm keeping all the numbers. So how do we find the vertical displacement? Subat equation without t is going to be S is ut plus 1/2 at squared. Substitute everything, so S is 26 point, no, I don't want t, sorry, not this one. So v squared is u squared plus 2as, v squared is 0, u is 26.56 squared minus 2 times 9.8 times s, and s is 36 meters. Yeah, just solving this linear equation and keeping these decimals, all the decimals in the calculator. And then last question that they ask is, the model does not include a resistance. State one other limitation of the model. It's just one mark, and things that you can comment are related to modeling the ball as a particle. So for example, you are ignoring, apart from a resistance, you are ignoring spinning, spinning of the ball, like rotational effects, or for example, the wind, or you can mention that you could use a more accurate value of the gravity, but they are not asking you really how to improve it. They are asking you a limitation of the model. So it's better just to mention those things. Don't mention the mass or the weight of the particle, because that won't change anything. And that's all with this question.